Watch the data dance in line as Python takes control. Linear regression leads the way, predictions on a roll. Hello and welcome to AlgoStalk. It's time to put our linear regression knowledge into action. I'll assume you already understand the concepts and math behind it. If not, check out the links in the description to catch up. In this video, we'll fit a line using two methods. First, with math, and then using Scikit-Learn. We'll do it with and without the intercept, and see what information we can get from linear model. First, we import the libraries we need for our linear regression model. Then, we load the California housing dataset. After that, we organize the data into a data frame so it's easier to work with. We add a target column to store the housing prices we want to predict. Then we include an intercept column. We randomly select 10 rows to keep our example simple. Then we randomly split the data into two sets, one for training and one for testing. In both sets, we separate the features like house age from the target, which is the house price. We choose two columns, intercept and house age. House age helps us predict house prices and the intercept term is needed for our model. Y-train holds the actual house prices from our training data. These are the values our model will use to learn and make predictions. We'll explore two cases for linear regression. One with the intercept represented by the equation y equals c plus mx, and one without the intercept. In both cases, we'll see how the house age feature affects the house prices with and without the constant term. We create a scatter plot of house age versus target to see how house age affects prices. This visualization helps us understand the relationship between the feature and the house prices. Now that we have everything, it's time to build our model. We'll start by fitting the model using our mathematical understanding. Remember from our previous videos, the normal equation helps us find the best fit line. If you want to brush up on that, check out the links in description at the end of this video. First, we calculate the dot product of our feature matrix and its transpose, which is xt multiplied by x. Then we calculate the inverse of this matrix. Next, we calculate the dot product of our feature matrix transpose and the target values. Then we find the model coefficients theta by multiplying the inverse matrix with this dot product. This gives us the intercept and slope for our best fit line. This is how the line given by our model looks like. For any value of house age, say 30 here, we can predict its valuation by substituting the house age in the equation to get the valuation of 2.071. We add the intercept to the test data and combine it with the house age feature. This prepares the test data so we can use our model to make predictions. We calculate predictions using our model's coefficient theta. For each row in the test data, we compute the predicted house prices based on these coefficients. Using our mathematical understanding with the intercept, the equation is target equals 2.679 plus minus 0.0202 multiplied by house age. Next, we find the equation without the intercept. To get the equation without the intercept, we simply remove the intercept term from our original equation. So, with the intercept, the equation is target equals 2.679 plus minus 0.0202 multiplied by house age. Without the intercept, it simplifies to target equals minus 0.02 multiplied by house age. And visually, the line shifts down. But is it the best way to do? Pause the video and think for a couple of seconds here. To correctly find the best line without intercept, we would need to again solve the normal equation with some changes in our training data. When we remove the intercept for training, our model focuses only on how house age affects house prices. This means the model will look at the direct relationship between house age and price without any constant offset. And the best fitted line would look like this. Target equals 0.041 multiplied by house age. Performing linear regression with just a few lines of code is indeed simple, but our goal was to understand the process better and validate our results. Scikit-Learn is a trusted library that provides reliable results. Now, let's compare our manual results with those from Scikit-Learn to see how well they match. We use Scikit-Learn's linear regression class to perform linear regression. This model automatically handles the intercept for us, making the process straightforward and efficient. You don't need to specify fit intercept equals true, as it's the default setting. However, I've mentioned it as a hint for a task I'll ask you to do at the end of the video. With Scikit-Learn, we can predict house prices using our trained model. It provides us with the intercept, slope, and predictions with just a few lines of code. In summary, our manual implementation matched Scikit-Learn's results, validating both our grasp of math and library's accuracy. I hope you find out the line without intercept yourself now. While libraries like Scikit-Learn simplify coding, understanding the underlying concept is essential for true mastery. Use these tools for efficiency, but always appreciate the math that drives them. This balance will enhance both your skills and your appreciation of the techniques at play. Thank you for exploring linear regression with me. Keep coding and keep learning. This video, don't forget to like, comment and subscribe to support the channel.